Let's now look at a few exam questions about type 1 and type 2 errors. The first of which is this one. It's a paper 7 from June 2007, and it's question 4. It says, at a certain airport, 20% of people take longer than an hour to check in. A new computer system is installed, and it is claimed that this will reduce the time to check in. It is decided to accept the claim if, for a random sample of 22 people, the number taking longer than an hour to check in is either 0 or 1. First question, calculate the significance level of the test. Okay, so what is the key information that you should retrieve from that text? H0, the null hypothesis, that is the probability is 20%, 0.2. And the alternative hypothesis is that it's smaller than 0.2. As you can see here, the computer system is installed and is claimed that this will reduce the time to check in. So you will have less than 20% of the people taking longer than an hour to check in. Okay. You have X as being the number of people taking longer than 1 hour to check in. So you have a binomial distribution with n22 and the probability 0.2. The significance level of the test, what is that? The significance level is the probability of rejecting the null hypothesis when it is actually true. Since the claim is accepted when X is 0 or 1, this is the rejection region for the null hypothesis. So the significance level is calculated using P equals, the probability that X is smaller or equal to 1 under H0, which is corresponds to a probability of 0.2. So let's just calculate that. Here I don't have the calculations, you already know how to do that. And I have an overall value of 4.8%. Okay? Now, state the probability that a type 1 error occurs. What is the probability of a type 1 error? The probability of a type 1 error is the significance level of the test. That's all you need to know. So you already calculated that. It's 0.048. Calculate the probability that the type 2 error occurs if the probability that a person takes longer than an hour to check in is now 0.09. Okay, see how the circumstances have changed? No longer 0.2, it's now 0.09. So it's a probability of a type 2 error. So when does this happen? The probability of a type 2 error occurs when we fail to reject H0, although it is false. Let me put this bigger. Although it is false. Since we reject H0 when X is smaller or equal to 1, as we saw before, we fail to reject it when X is bigger or equal to 2. Therefore, under H1, under the alternative hypothesis with P equals 0.09, we must calculate the probability that X is bigger or equal to 2, which is 1 minus the probability that X is smaller or equal to 1, which we now are going to calculate, but with a different value of P, no longer 0.2, it's going to be 0.09, okay? You do that, calculate, again, I'm not showing the calculation, I have here the probability is going to be about 60.1%, okay? The probability of a type 2 error under these new circumstances. Let's go to another one, paper 7. This is from 2005, I think. Yeah, 2005. It's question 2. It says, a manufacturer claims that 20% of sugar-coated chocolate beans are red. George suspects that this percentage is actually less than 20%, and so he takes a random sample of 15 chocolate beans and performs a hypothesis test with a null hypothesis P equals 0.2 against the alternative hypothesis of P smaller than 0.2. he decides to reject a null hypothesis in favor of the alternative hypothesis if there are 0 or 1 red beans in the sample. With reference to this situation, explain what is meant by a type 1 error. Again, what is a type 1 error? A type 1 error occurs. Let me go there first. So here in green, the circumstances of the question. A type 1 error would occur if the null hypothesis would be rejected for finding just 0 or 1 red beans in the sample of 15, although 20% of the overall chocolate beans are red. Okay? So you would reject the null hypothesis, although 20% of the overall chocolate beans are red. Next question. Find the probability of a type 1, find the probability of a type 1 error in George's test. Okay? Again, you have to calculate the probability that x is smaller or equal to 1, that is George's test, under H0. This is basically the significance level of the test. This is pointing to this, not just this part over here. So just calculate it under these circumstances, and you have here the significance level of the test, which corresponds, obviously, to the probability of a type 1 error. Last one is also a paper 7. Obviously, this one is from 2009. It's question 4. In a certain city, it is necessary to pass a driving test in order to be allowed to drive a car. The probability of passing the driving test at the first attempt is 0.36 on average. A particular driving instructor claims that the probability of his pupils passing at the first attempt is higher than 0.36. A random sample of 8 of his pupils showed that 7 passed at the first attempt. Okay? Carry out now an appropriate hypothesis test to test the driving instructor's claim using a significance level of 5%. So it seems pretty good, 7 out of 8. So let's make the test. Okay, so here the null hypothesis is that the probability is 0.36. The alternative is that the probability is bigger than 0.36. X is the number of students passing the test at the first attempt. This is the test that you are going to use. So the probability that X is bigger or equal to 7 under H0 must be smaller than 5%, which is the significance level that we have chose, or the criteria that we are going to use to either reject or not H0. Okay, so in this case, since you only have 8, we are calculating the probability that X equals 7 and X equals 8. And here you have it. This is smaller than 5%. So it means that there is sufficient evidence at the 5% significance level to support the instructor's claim that the probability of his pupils passing first time is higher than 0.36. Okay? But now look at the second question. The second question is asking this. In fact, most of this random sample happen to be careful and sensible drivers. State which type of error in the hypothesis test, a type 1 or a type 2 error, could have been made in these circumstances, and find the probability that this type of error when a sample of size 8 is used for the test. So if the drivers are careful and sensible drivers, doesn't mean that he chose them on purpose, really doesn't matter, but if they are, what will this mean in relation to the test? The sample is biased, okay? The drivers are careful and sensible, so the sample is unwillingly biased towards what? Towards rejecting H0, towards saying that this driver, this instructor is above average, if you will, okay? So if you are biased towards rejecting H0, there's a risk of rejecting H0, albeit being true, which constitutes what? Constitutes a type 1 error, okay? The probability of a type 1 error is equal to the significance level of the test itself, not the value that we used here for our decision rule, is the actual significance level of the test. So that's what I did here. Under these circumstances, I calculated the probability of x being equal to 8, 7, 6, etc. And I found the rejection region, okay? This one is 0.0293, okay, when x is bigger or equal to 6. When x is smaller or equal to, bigger or equal to 5, the probability of that happening is already bigger than 5%, okay? So the actual significance level of the test is this, which is also the probability of the type 1 error, the one that we calculated here.